Hello, everyone. So this week we're going to pick up with a concept that's really similar to what we learned last week about conjugated dienes and talk about something called aromatic compounds or aromaticity. It's going to be a very similar theme. First thing we're going to do, though, is introduce benzene and benzene derivatives and specifically the nomenclature for these compounds. Okay. So one of the things that we've talked about kind of a lot in organic chemistry, but we actually haven't discussed reactions of it really, is benzene. This is a really, really famous aromatic molecule. We'll talk about what that aromatic means. But yeah, it's just a really famous molecule in the history of organic chemistry. It was discovered relatively early on, and it's got a lot of quirky qualities to it, okay? In addition to talking about benzene, we're also going to talk about some derivatives of benzene, okay? So an example would be this guy right here. It's a benzene with a methyl group. The pain in the butt about benzene and benzene derivatives, a lot of them have their own special names. Well, like you would want to call this methylbenzene. Unfortunately, somewhere in the history of chemistry, it's got its own special name. It's toluene, okay? Similarly, if it's got two methyl groups, we'd want to call it dimethylbenzene or something like that. But no, this one has its own special name, xylene, okay? And this ortho will also talk about what that means. Just a preview, it has to do with the fact that these two are right next to each other. Okay, so that's the first thing, is that it's an unfortunate fact of life that in organic chemistry, you're just going to have memorized these benzene derivatives. Okay, so let's introduce them. Actually, first we can talk about the simpler ones to name. And that is these ones that have monosubstituted benzenes that don't really have special names, so to speak. So this guy here is indeed chlorobenzene, right? The benzene is kind of treated as the parent chain, and then those halogens, chloro, bromo, iodo, those are always prefixes, so they just go before the name, right? Likewise, I mean, this we did with BR, this would be bromo benzene, etc. Okay, this guy right here, NO2, this is a nitro group. So this is nitrobenzene. And then alkyl groups, we said that the methyl group has its special name, but other alkyl groups you just name like you normally would. In this case, there are 2 carbons, so it's an ethyl group. So this is ethylbenzene, okay? So not everything has a special name, but some of them do. In particular, these are good examples. The nitro group, chlorobenzene, the halogens, another example would be, this would be cyanobenzene, okay? But again, a lot of them actually have their own sort of special names. So these are the 8 that you're gonna have to have memorized, okay? So let's just go through them real quick. Toluene, as we said, that is just benzene with a methyl group on there. If benzene has an alcohol group directly attached to it, that is phenol. If it has this methyl ether group, that is going to be anisole. An amine group, you have aniline. These ones aren't too bad. It's a carboxylic acid, so that's benzoic acid. It's an aldehyde group, so that's benzaldehyde. This is a ketone with just that small methyl group on the other side, and that's acetophenone. And then when it's got the double bond directly next to that benzene ring, or one removed, that is styrene, okay? Flashcardum, unfortunately, it's just a fact of life that you're gonna have to know these benzene derivatives names, okay? Because they're actually going to be the common name. So what we're gonna, or I'm sorry, not the common name. They're going to be the parent name for other derivatives. So for example, if there was a chloro group here, that would be chlorophenol, right? You're not just going to consider the benzene ring to be the parent chain. It's gonna be that whole thing. Okay, so we'll go through that in some examples there. But that's why memorizing these are gonna be so important. an integral part to the benzene nomenclature. Okay, so we said that alkyl groups you would name sort of like ethyl benzene. Another example would be if there are 1, 2, 3 carbons, what would that group be? That's propyl benzene. Ooh, with an E on the end. However, as soon as that alkyl substituent becomes larger than that benzene ring, so when it gets to be 7 carbons or more, then you don't consider the benzene ring to be the parent chain, you consider that alkyl chain to be. So now in this 1, 2, whoops, 1, 2, 3, 4, 5, 6, 7. So the parent chain there is a heptane, right? And then when you're referring to a benzene ring as a substituent, it's called a phenyl group. Okay, so in this case, this would be 1 phenylheptane. Just to do another example here, let's say that we had something like this, where we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. So this would be 3 phenyl octane, right? Because that phenyl group is on that 3rd carbon. Because benzene rings are so big, they're kind of like a pain in the butt to draw all the time. So you will often see it abbreviated as just this pH. Apparently this phi sign too, I've literally never seen that in my life. But this is really common as a way to shorthand those big benzene rings or phenyl groups. Okay, now let's talk about the orthometa-para, which is a way to describe the location of different substituents on di-substituted benzenes. So in this case, we're going to take these dimethyl benzenes. We already said that they have this special name, xylene, right? Notice that these are all xylenes because they're all dimethyl benzenes, but then they have this orthometa-para. That is a designation that lets you know how far apart those substituents are. Okay, so ortho is when they are directly next to each other. Meta is when they are 1 apart. And para is when they're on the opposite sides of the rings. Okay, so that's how we sort of refer to di-substituted compounds. So for example, if we had something like this would be ortho dichlorobenzene. There is an acceptable convention where you could do it as 1,2 dichlorobenzene. They're actually both accepted. However, I'm going to force you guys to practice the orthometa-para designations. So when we're talking about di-substituted benzenes, we're always going to use that orthometa-para convention, just to get the habit of practicing it, because I know that it's going to be on the ACS exam. It's just something you got to know. How do you remember it? How I remember it, one thing you'll learn about me as a teacher is I often like to use stupid, silly things to help something stick into my brain. So for this one, everybody knows OMG. This is OMP. And then you can get it really stuck in your brain if you say it's super silly, like a valid girl, like OMP. Okay, so then that tells you, right, that's the order. Ortho, meta, para, are right next to each other, 1 apart, 2 apart. Okay. So then let's look at some of these names real quick and pick them apart. As we discussed, the halogens, as well as that nitro group, those are just like prefixes, okay? So then let's pick this name apart. First of all, our 2 groups are 1 apart. Actually, let's start from the back. Let's start from the parent. We have this special name here, which was anisole, right? That's going to be the parent chain here is going to be that special group, a benzene ring with that ether group on it. And then this is nitroanisole because that has the substituent. And then because those substituents are located just right next to one another, it is orthonitroanisole. Okay, so this is going to be the procedure. You got to find the parent chain just like always, but it's a little bit harder because of all those common names that we have to remember. And then construct everything. Again, specific for di-substituted, you're going to use that orthometapara. So then let's go for the other ones, the next one. So in this one here is our special parent chain, which we called toluene. Okay, there is a bromo substituent, and they are located 1 and 3 apart. So that is why it is a even color code here. 1, 3. So that's why it is a meta-bromotoluene. Keep on going here. So find the parent chain. In this case, this guy is our special parent chain. That is benzaldehyde. It has a chloro substituent, so it's chlorobenzaldehyde. And then they are located 1, 2, 3, 4, 1, 4 apart, which is para on opposite sides. Okay, so it's para-chlorobenzaldehyde. Okay, cool. All right, so that's the strategy we're going to use. We're going to identify the parent chain. Again, this is the step that's kind of a little bit harder because we got to remember all those benzene derivative names. Then we're going to identify and name the substituents. We're going to number the parent chain and assign the locants or the numbers to each substituent. Remember, if it's di-substituted, we're going to use that orthometapara prefix. If it's tri-substituted, you'll actually just use, or more, you'll use the numbering scheme. So we'll go through some examples of that. And then list the numbered substituents before the parent name and in alphabetical order, just like always. Okay, so here, let's go through this procedure here. We have to identify the parent chain. In this case, it's one of those special benzene derivatives that has its own name, which is phenol. Then we're going to name and locate these substituents here. In this case, there are bromo groups. And then we got to find their location. In this case, it's tri-substituted, right? So you can't use the orthometapara. This is one of the very common mistakes that people make, is to try to use orthometapara when it's not appropriate. It only works for di-substituted benzenes. If there's more than that, you can't use it. So in this case, we're going to have to number. The special group that was a part of the parent chain always gets carbon 1. Okay, so this is carbon 1 here, and then we just go around 2, 3, 4, 5, 6. In this, if we went the other way, so just like always, you want to try the 2 numbering schemes, 1, 2, 3, 4, 5, 6. In this case, it's equivalent, so we don't have to worry too much. And we have 3, 5 dibromophenol. Okay, so again, just sort of going through the procedure one more time. That special group that was on our parent chain, right? That's what made it a phenol. That always gets carbon 1. So then we just continue in a circle, which is why our bromo groups are located at 3, 5. Okay, so let's just go through these examples again. Well, these are the ones that we did before, so let's actually switch it up a little bit. Put a chloro group there. That'll be good. Okay, so first thing we're going to do, we're going to identify the parent chain. In this case, that is the special benzaldehyde group. Now you got to go through and find the location of those chloro groups. Since it's tri-substituted in this example, we're not going to be able to use the orthometapara. If it's di-substituted like back here on this one, we will. But let's go through and we're going to now number. The safest way to do it, if you can't see it right off the bat, is to try in the 2 directions. Remember that special group always gets 1. So if we go, let's do clockwise first, 3, 4, 5, 6. And the other way around would be 1, 2, 3, 4, 5, 6. So which numbering scheme is correct, the red or the green? All right, hopefully, remember, we're going to pick the numbering scheme that gives us the lowest numbers. The red, it would be 4 and 5. In the green, it's 3 and 4, so the green wins. So this is 3, 4 dichlorobenzaldehyde, all one word. Okay. Let's do this next one here. So this is a good example because we're going to see that first we're going to have to identify the fact that this is one of those special parent chains. It's a toluene. Now we have these two numbering schemes that we're going to try out. Go clockwise first. Remember that because this is what makes it a toluene, that's what gets carbon 1, 2, 3, 4, 5, 6. Going the other way, 1, 2, 3, 4, 5, 6. So in the blue numbering scheme, it's a 3, 5. And in the red numbering scheme, it's a 3, 5. Okay, so now which one are we going to pick? Remember, if it's a tie, that's when you go to alphabetical order. So because bromo comes before chloro, it's going to be 3 bromo, 5, not have enough room, chloro, toluene. All right, and then the last one, remember we're going to first pick out the parent chain. In this case, it is that anisole, right? That special ether group off the benzene. Your substituent is going to be a nitro, so it's nitroanisole. And then because this is a di-substituted benzene, instead of using the numbering scheme, which would just be 1, 2, I'm going to instead use that special orthometa-para. Which one would it be, orthometa or para? In this case, right? O is our first one in OMP, which is when they're right next to each other. So ortho nitroanisole. One of the things that I want to do this example as well, because we're not going to be, like if we go back to our list of special parent chains here, you're not going to have to worry about when these substituents are kind of like mixed. By that, I mean an aniline that also has or a benzene that has both an amine group and an alcohol group. We're not going to worry about that. Or if it has, an alcohol group and an aldehyde group, stuff like that. These like mixed functional group ones, we don't have to worry about, with the exception of the alkyl group, okay? Toluene is the parent chain when there's like a chloro group or a nitro group, but if there's anything else that's more special than that, an alcohol group, it's not going to be a toluene, you're just gonna refer to that as a methyl group. So let's do this example here, show you what I mean. So here, we kind of like have, well, I don't know, this could be a parent chain here, a toluene, but this could be a parent chain here, the phenol. And so what I'm trying to say is that the phenol is going to win. Toluene would be the case if they're just halogen groups like up here, or nitro groups, but anything more fancy than that, alcohols, amines, aldehydes, ethers, blah, 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 blah. You won't have a parent chain of toluene. It's going to be whatever the other thing is. So in this case, our parent chain is the phenol group. And then we have a methyl. So this is now methyl phenol. And how am I going to refer to the spacing there? This is meta-methylphenol. Okay. I think that's it. Yeah. Notice that you can also just abbreviate with the first letter. I like to write it out just so I can hammer this orthometa-para thing home. Again, the convention is, it's not like illegal to use the numbering scheme as opposed to orthometa-para, But for di-substituted benzenes, I want you guys to know this orthometa pair really well. It's going to be really important going on, when we start talking about reactions of benzenes. So what I'm going to be looking for, and I'll be explicit, is naming di-substituted benzenes using the orthometa para naming scheme.